Okay, hello everyone. You're all welcome to week 3 lab session. And in this lab session, we're going to be looking at the aggregate functions. We're going to focus on the group by and also conditions on the group structure, which is the use of the having clause. So I want us to begin by looking at a dashboard. This is what you're going to be building the second module in Power BI. So this dashboard, I want us to take a look at it. First thing, when you're given an exercise to build a dashboard, you have to connect it to data source. I'm just going to walk you through the steps. So these dashboards, I did this in Tableau. You're going to study Power BI in the next module. So if you notice, I'm connected to SQL Server. These are the different sources that are available. I'm connected to SQL Server. And once I connect to SQL Server, if you look at this, the server name, this is the same server we connect to when we're connecting to SQL Server Management Studio. If I click on this button, this same information right here, that's the server name. So this same information you see right here is the server name. That's the same information I'm using in Tableau to connect to that same server. So you're going to see is the same information right here. So SQL Server Management Studio is connected to this server. I've also used Tableau to connect to that same server. Right. Now, once I'm connected to that, I specify the type of the database I want to analyze. It's the same thing we do in Management Studio. Once we connected to the server, we create a new page. That's a new script, and we use this. So I want us all to open a new page, a new editor, and just connect to the CVS Health database. All right. So this is what we're doing in SQL Server Management Studio. So it connects to the CVS Health database. The connected database is shown in this box right here. Right. And the list of databases is what you see right here. And the same information is what you see in the databases folder. It contains a list of databases you have. And that's the same thing I see in Tableau. When I connect to that server, I see the list of databases right here. See that? And I can choose the one I want to analyze, CVS Health. In Management Studio, we just simply write this code and execute. And this is a declaration, this database we want to connect. See? I can also build a query and just copy the query and embed it within Tableau. If I look at this, is a query. This right here is a query I've embedded. This query was built in Management Studio, and I just copied and ran it in Tableau. You see, that's the same query. This is a code. So this query, if I can click on preview the results, it's going to generate this. This is like doing the select star from a table, right? So the goal of this explanation is just to show you that all dashboards that you build, they have data running behind the system. These are not static images. And if there's an update in the data from the database you're analyzing, it will be reflected in the images, in the pictures or the charts you see right here. Right. So I want us to do this chart by chart. I'm going to project this. I want you to look at the visual and then try to visualize the SQL behind this process. For example, I'm looking at the total sales right here. Right, this number you see right here is the total sales. If you go to that table, the main table we're going to be analyzing is the pharmacy sales inside this database CVS Health. So there's just one table, I think. And if you go to that table, it's this right here. All right, so you can also begin this process by just doing our base query, which is the select star from dbo.pharmacy sales, which is this. So first we connect to the database and then we target the table we want to analyze. We do a base query on it just to get used to the different columns that are available in that. See that? Right. And if you notice this, we're going to do it one visual after the other. Right. So let's look at this number and just try to challenge yourself. We will ask to write the SQL query behind this number. Right. This is what total sales. So this is the total sales, and we formatted it in million. This is just we formatted it, we put a dollar sign. But this formatting will be done in the visualization application. We don't really bother about formatting inside SQL Server Management Studio. Right. So what we're going to do there is just to get the total sales. So on that new document you've opened, we're going to start this process, total sales. Right. So you're going to build the query to generate that number, total sales. So I'm going to be using this. This is a screenshot you all have. We're using this. So this first one is total sales. So let's write the query that will generate this total sales number. And that's when you now go back to the table you have and you go through the columns we have, the total sales right here. But this is going to be aggregation, right? You're not just going to call this the column and you're listing the values. Now, if you look at this right here, it is a summation process that has taken place to generate this single value, right? So if you attempt to do this and you call just the total sales column, and that's not enough, you're just going to be showing the individual values inside that column. So if I execute this, I get the columns, the column and all the values inside. That's not how this value was generated. This is an aggregation process, meaning that what an aggregate function was used. So an aggregation process will involve any of these aggregate functions right here. You can either be doing the mean, investigating the minimum value in a column, or the max. This is really, really very important, right? So you have to be able to look at the requirement and know if aggregation is needed or not. Right. Aggregation is needed to get this value. This you have to sum up all the values in the total sales column. So you have to be applying an aggregate function. We're going to be targeting the sum function on the total sales column to generate that value. So these functions, you have to remember the mean, max, sum. There's also average, AVG. We've seen this, and what's the last one? Count. So these are key aggregate functions that every data analyst must know. See that? So if you're looking at this, this is showing the total sales, and we are getting one value. It therefore means that aggregation was done on that sales column. You have to aggregate all these values, and the correct aggregation to use is the sum. So I'm going to target this column and apply the sum function to it. Right. And of course, I am generating a new column. I've applied logic on this. I'm generating a new column. The column shows up without a name. All of these aggregate functions, they are meant to return a single value without any breakdown. I'm not breaking down total sales by product, by maybe drugs or manufacturer. That's a breakdown. I'm just showing the total sales. So a single value will be obtained. What is the average age of students in class? You're going to get a single value. If you now start doing average age by gender, you're going to get two values representing the two gender groups. That's a breakdown analysis. So here we're not breaking it down. It's not a pair analysis. We're just looking at total sales. You see that? So you always get a single value, right? If you want to break this out, then you're going to need some other column to break out this, right? So always remember that these aggregate functions will return a single value. They will process a set of values and return a single value. When you're doing a top level analysis, there's no breakdown on that. Average age of students, you're going to get one value. Average age of students by gender, you're going to get two values because of the two gender levels. You see that? This is very important. So visualizing this, you know, this is an aggregation. We are targeting a column and we are doing an aggregate on the column, and the aggregation use here is what? Sum. And that's exactly what we've done. If I dismiss this, I free out the column and I just project the individual values in that column. You have to know the difference. Right? If you actually want to sum up all of this into one value, you have to apply an aggregate function. Aggregate means bring things together, aggregation, right? So pulling things together, this will now be what we're going to call the total sales. Right. Please do the same at your end. Right. Once you see me typing this, just go ahead and do the same at your end. Right. Now this value has been formatted inside SQL Server Management Studio. See that? inside the visualization application, you're going to do formatting in Tableau in Power BI as well. Right. So this value has been formatted to million, two decimal places. Right. So instead of showing the full value you see right here, it has been formatted to million stuff. It is very, very easy. Formatting is a very popular concept in most visualization tools. So total sales, this is a formatting option right here. You're going to see the same in Power BI. Right. And the number format I've gone for is currency custom. You see, display unit is in millions as M, and I'm displaying two decimal places. That's just the arrangements you do. There's nothing coding on this. Right. But you have to understand the SQL that is going on behind the scene for this to be projected, and that's the focus. Right. So that in the next model you're going to be building this stuff, you understand what is going on behind the scene. See that? And also right here, you see each of these values they have all been aggregated, sum of total sales, which is the same thing we've done in SQL. Sum of the total sales to get this total sales. So that's that value right there. See? Any questions so far? Please, this is a practice session. Try practicing it out. If you have any question, let me know. We're gonna do that for all the three matrices you see on that image. I did send this image. You're gonna see that this CVS Pharmacy Analytics. This is it's an image, it's a screenshot of that dashboard. I want you to familiarize yourself with the concept of dashboards. All right, so that when you go to the second module, you start building it. But for now, we can just take a look at a given dashboard, see a matrix, and be able to write the SQL behind that matrix. If you're done with total sales, you can just go to the total cost. It's going to be the same thing. All right, we're just going to change the column of interest. So for total sales, total cost. So the next one we're going to do is, if I'm too fast, you slow me down. All right. If you go back to the base query execute, we have a column that we can use for cost. It's going to be this is the cost of goods sold. This COGS, that's the cost of goods sold. And usually when you see something like that, you can always go to Google and search, or most often the business requirement document will have that stuff spelled out. So if you look at total cost right here, if I go to the calculation, it's the cost of goods sold. Right. So I'm going to be summing up on that column for the total cost. Right. Again, back to the base query. This. So the cost of goods sold is this column right here. This is on group data. When you see something written like that, that's on group data. You're seeing the individual values in that column. It's on group. Now, when you start doing aggregation, you have to first of all choose the aggregate function to use. On this, we are following this dashboard. It's talking about the total cost as the metrics we're tracking right here. So we need to transform this into an aggregate, and we're going to apply the sum function to it. Right, and this we generate a new column called total cost. I need the space, so I'm going to use the square bracket because of the space right here, and this is it. So this same value is what has been formatted right here. As we proceed in the training, I'm going to teach you about a function in SQL called format. Yes, you can use that, but I think this is not the focus for today. So the format function, so you've rendered something and you just want to go ahead and format it. Usually you have to declare C's for currency. And usually the default currency is the US dollar. So if I execute, so this is what I'm trying to do. I want to format this outcome into a currency. See, there's for currency. All right, this is not the focus for today. See, it has automatically brought into the dollar. You see that this is 222 million. And we have just discarded this part and rendered it easy on this side. 222.73 million. Right. Yeah, so we'll get to that. This is formatting. It's a simple function, right? And when you just put a comma, I want to format this as a what? A currency. C is for currency, right? Yes, I'm going to dismiss that. That's not what we're going to cover today, right? So please go ahead and do the first three matrices at the very top: total sales, total cost, and total profit. And if you have any questions, just let me know. So for the total profit, I always have to go back to the base query, identify the column on which you're going to build the logic, right? So back to the base query. So cost of goods sold, and most of you are into the businesses, cost of goods sold minus the total sales will always give you the profit. Cost of goods sold, what's the cost of making the good and how much did you sell it? So what's your profit? This minus this. If you go right here, this is the profit. Right, if I edit this calculation, I'm going to see it is the total sales minus this. So the cost of manufacturing a good and how much did you sell that good. So if you deduct these two quantities, you're going to get the profit out of it. Right, but I'm going to be looking at it from an aggregation perspective. So total profit, you know the cost of goods sold, you know the selling price, you can get the profit from that. Right. So you can actually take this, the summation of this, minus the summation of this. So we'll keep it aggregated. So we're basically taking this value computed right here, which is this. I can just copy this value and run a primitive way of doing this minus, and I run this value, which is the cost of goods. So this value right here. So that's basically what we're trying to do. Right. This is just static. We want it to be column driven so that if the values change, this is going to go into the database and compute it and generate this and then compute this and then now do the subtraction. So you see we are just including that, so summation of this minus the summation of this, right? Then I'm going to run this. See, this is what we get, right? I'm going to copy this value and let's test it with what we have on this side. I'm just putting that as a comment so that it doesn't affect this. I'm going to run this part right here. Yes, and that's the same value we get. All right, but this is just proof of concept. I don't want you to do this. Everything should be column driven. This is static coding. When you just hard code a value, hard code another value. What if the selling price of a product changes? You've hard coded this, it's not going to be updated. See, but then if you leave it in the calculation, it will go ahead and always return the accurate value. So this is dynamic coding, while this is static coding. The data analyst should never engage in static coding. Right? Your analytics should be driven by what the database is saying. So if you hard code values like this, right, it's not a good practice. That was just to test that concept, right? So this is what you should normally do. So at any given moment, this will compute based on what is currently going on in the database table. Also, this will be computed, and this is the logic to get that total profit. And now we can alias this as our total profit. Please stop me if you have a question. Right. So these are the three metrics I want us to build SQL, and you're seeing them from the dashboard. You can build the SQL queries behind this. Of course, if you're working in a project, you're going to first of all come up with a complete query that has all of this. But I just want us to run them individually, right? So you understand. And moving forward, you're going to be seeing dashboards from a different perspective. You're running the SQL behind the numbers you're seeing up front, right? And that's a very important skill set I want us to have, right? The concept of dashboard, you keep seeing it, right? Dashboard. If I go to images, sales dashboard, this is what I'm talking about. So you have to understand that behind each of these numbers, there are calculations going on to generate and project this on the screen. It's an excellent dashboard you see right here. So total revenue, there must be a revenue column or something that you're going to sum up. This is summation. This is aggregation, right? This is percentage calculation, and then it is formatted with the dollar in front of you and stuff like that. New customer, this is counts of customers. Maybe there's a customer ID. You can do the count on the customer ID. See that? All right. So that's what I want to prepare your mind. And if I take you to LinkedIn, and you're going to see people sharing some very interesting dashboards. By the time you go into the second model, these things are going to become very, very interesting. If I'm lucky, I should be able to see somebody has posted. Right, this is poor dashboard design. It's a background image which is blurring out the key aspects of your visual. But it's also, this is a Walmart sales dashboard. You see, this numbers you project at the top. There's some metrics you're tracking. It's a nice dashboard, but the design, the background image is not a good idea. It's actually, interfering with the visualization, right? But that's a good attempt at building a dashboard. Right. So I want you to start looking at dashboards different, right? Even before you get into it, start looking at it from a SQL perspective, right? Those numbers, you can now start running the query behind the scene in order to have a better understanding of those, the metrics you're seeing right there. Okay, so let's get these three numbers. If there are any questions, please ask before we go to the next segment. I'm going to pause right here so that you can complete these three, right? And make sure you save, right? You can go to click on the save icon. This is the CVS Pharmacy Analytics. Where should we save this? Of course, they should go in your week 3 lab. So if I go to this week 3 lab, right, I'm going to save this. It's a SQL file, CVS Pharmacy Analytics. I'm going to save that in week 3 lab. And then you just keep building. As you're building, you keep clicking on the save button. Right. So any question before we go on the next segment, or you still need time to build? So please feel free to pause me and ask a question. We are just tracking these three metrics you see at the very top. Okay, I need somebody to work on this one. So we're looking at the manufacturer insights. So please zoom into the title. This is total sales and profit. And we are doing this. This is basically total sales and profit by manufacturer. And that's the key message we're going to take from this visual. We are tracking two metrics, total sales and total profit by manufacturer. So I'm going to transform this into a business requirement from a SQL perspective. So let's write a query to address this. Let's write a query that will show the total sales and profit, total sales and total profit by manufacturer. Total sales and total profit by manufacturer. This is what that chart is capturing. So let's transform this into a SQL query. Right. I need somebody to volunteer and do this. So first you have to explore that table.
I can give it a try.
Okay. Alex, I'm going to share your screen. Which screen do you want me to share? It looks like you have two screens.
Can you share from the one named Alex?
Okay, yeah. So let's do this together. So the goal is to look at we are tracking two key points, total sales and total profit. And this is an example of a breakdown analysis because we're doing it pair by manufacturer, right? So I want us to solve this together. So yeah, so let's go ahead and do that. Total sales and total profit by manufacturer.
Let's see. The first thing we'll do is I just like to before I like go on with an exercise, I just like to like check the content on the table to see like the various what can I say content on how things are listed and so on.
Excellent.
Let's see.
Yeah, that's a good practice.
Manufacturer. So then the question is to total sales. So first of all, we have to call the two columns total sales and manufacturer. So we do sales to begin with, which is listed as total sales here. Then we do aggregate those later. Then we do, and of course the sales. The profit is going to be. So let's do this first. COG. And now let's aggregate this with some sales. This down. Some this as well as total. Then from let's see, there's a mistake here somewhere. Some I forgot the comma here. Then from there on, we do the aggregate of this total sales, generate a profit. Minus cost of goods sold. Minus total profit. And from there on, we say total sales and profit by, let me say group by manufacturer. What is it? Let's give this entry answer the code first. I forgot to include the manufacturer cost. What's happening? Mm, let's see.
First of all, put a comma and then you type. It's gonna show up. Yeah, yeah. Put a comma and then you type in front, at the back of the comma.
Yeah, behind.
Yeah, and behind.
Man.
Yeah.
Okay, there you go. Let's see.
Yes, this is excellent. Yeah. You can. So that's an excellent way to do that. You can now comment out or you can remove the total cost, and we just stick with total sales and then profit.
Wow.
Yeah. So, but that was an excellent way to demonstrate those the three components, and then how the two participate to generate the third one as a total profit. Yeah, this is excellent. Excellent, right there. Any question for Alex? This is excellent. I just remembered something. Let me share my screen and let's talk about this. I remember when I did this last time with a certain group of students. Student once asked, "What will happen?" Remember how we did the total profit? We took the total sales minus total cost of goods sold, right? So just imagine we did it this way. I'm going to show you another version of this. So this is one version. This is another version where you actually um, do the on aggregated columns first, like so. I'm just going to take this one out for now. You do the aggregations you do the on aggregated version like this, right? And then once you get this, you now proceed to do the summation. So I'm going to bundle all of this into a summation. So that's another way to do this. So sum. So after taking after subtracting the two quantities, we can now sum everything. Remember, when you do that, you get a single column and you can now sum up all of this. You see that? So now if I sum up all of this, this is what you get. One value right there. And you can compare it with what we had previously. So those are the two possibilities. You can, so this can be expanded to be this, which is this. And then this sum will also target this side if you open up the parenthesis, which is this. So this version and this version are the same. Let's run both of them so that we have two outputs. We can compare them. They are the same. So it all depends on how you want to proceed, how you reason this out. So this is the same, right? I just want to show you that you can try that. So you can sum the total sales minus the sum of the cost of goods sold to get a total profit. This is excellent. You can begin by deducting total sales from total cost of goods sold, and then you sum up that process. I want you to remember that this right here will give you a column and the values will be inside. You see, it's just similar to what Alex demonstrated. It's like putting this separately. See, this is the first column, and I put this separately, second column, and then I proceed now by doing the logic which generates the profit. So these are the separate columns, the two we get separately, and then we do this manipulation. So this is three columns. This is one, total sales, two, cost of goods sold, and then this is the calculation or the logic for profit, which is that column minus that column. This is what you get. Right. So if you want to go individually, this query is executed for each row. First row is going to be this value minus this value to get this. Right. So this company actually sold a product less than what the cost of manufacturing was. That's why the profit here is negative. Right. But anyway, you can understand that. So the goal right here is to show you can skip this phase, right, and do the subtraction, and then bundle everything in the summation, right? So I want you to see how this generates a single column. This minus this generates a single column. That's our profit. And then we sum up all of these values. That's what we're doing when we now, introduce the sum function across that entire logic, right? And it's still a valid way to do that, right? Or you can just target it by this minus this, which is still valid. So I want you to add that to that list so that you can. So this is option 1 for the total profit. Let's call this option 1, right? And I want you to practice both. This is option 1, but most people will go with this one, right? This is option 1. And then still on the total profit, this is going to be option 2, right? Please practice both versions and understand it, right? And if you look at upon execution, you get the same result, right? Yeah, I'm going to save this. I'll give you time to explore this new option right here. Make sure you document option 1 and option 2. Maybe I'm too fast. I'm going to slow down a little bit before we proceed to demonstrating this part, what Alex did on the screen. So please, let's catch up with this. Have these two versions typed out and execute both, and make sure you have the same result, right? And understand the two steps, right? They are the same. If you have any question, please, I'm here for you. Right? I can always come to your screen and let's take a look at it. And always learn to space out your work. Don't twist things, right? So instead of having these long numbers, you see, you have to understand that on the visual formatting was done, and you see a lot. Let me see. Let me go back to that sales dashboard I showed earlier. You see, when it comes to metrics, it's always formatted. Managers don't like to see those long numbers. It's boring. See, this is the formatting I'm talking about. See, it's always formatted. Formatting is an essential part of the data visualization process. You have to beautify your dashboard. It's like the aesthetics is very, very important. You see, all of the numbers displayed, they are nicely formatted. See that? But anybody looking at it, if you look at the currency, you should know it's a currency value, right? All they are nicely formatted. But SQL will just give you those numbers. SQL is not, the Management Studio is not an excellent, of course, the goal of Management Studio, this application is not visualization, right? It's for you to be able to use the SQL language to interact with the database, right? And then upfront, you can now build these amazing visuals, so that customer or the business can use that, to understand their data and make what we call data-driven decision, right? Business decisions are made based on analytics, the results, the insights that uh, data analysts generate from analyzing data, right? So formatting is an essential part. You see, all of these numbers are nicely formatted. Yes, so, but right now we're fine. We're making good progress. Okay, let's address this one. I'm just going to go over it again. So Alex did an excellent job on that demonstration, right? So this is very important, understanding the business requirement, right? I also want to train you on this aspect of looking at the visual, right? And then immediately you can put the SQL query behind that visual. Total sales and profit, and we are breaking that down by manufacturer. This is very, very important. This is a breakdown analysis. You're not going to get a single value for total sales or a single value for total profit. Now we've done that single analysis at the top. This is total sales, right? How does this sales breaks down across the different company, right? I forgot to give you an insight on this CVS Health. database. So CVS Health is a pharmacy in the US. So they buy pharmaceutical products from different companies. These are the manufacturers. And these are the pharmaceutical products they buy. These are the drugs. So these drugs are bought from these different companies. See that? And now they do sell this to customers. That's just the basics behind this stuff. Right? And maybe an interesting one, before we get to start doing the by manufacturer, we could just show a list of distinct manufacturers. Just generate a list of distinct manufacturers. I'm not going to put that word distinct, but you should understand you need the keyword distinct. So list of manufacturers. List of manufacturers. So this is where the companies that produce the drugs that are sold by CVS. So list of manufacturers, and then I also want you to generate a list of drugs. Right, list of manufacturers, list of drugs. Right, right. And then the list is not enough. I want you to also add a count of manufacturers. So what does it mean to list and what does it mean to count? So those are requirements I want us to add right here. So list of manufacturers, and then we're going to show counts of manufacturers or the number of manufacturers. Right, I think number should be the best for that. So number of manufacturers, right? And then we're not going to do the same for list of drugs, and we also do number of drugs, right? List of drugs, number of drugs, right? So these are simple investigations we can do before we now start doing this breakdown. How many manufacturers are available and how many drugs are available? Show me the list of manufacturers, list of drugs. So these are simple things we can address before, going into the deeper analytics. So of course, like always, we begin with this list of manufacturers. Can somebody, let me first of all project this. Tell me the column you're going to use and tell me the aggregate function we're going to use. No, sorry, this is a listing. We don't need any aggregation. We just target the column. All right. So this is list. They want to see the names of the manufacturers, list them out. So you're simply targeting this column. You see that? It's very important. We're just going to put manufacturer right there. So no analytics is done, no logic is applied to this. Just start and execute. And you have to understand that if the same drug, if multiple drugs are sold by the same manufacturer, then the manufacturer name will appear multiple times. See that? And it's an easy way to check this. Just do an order by. Right? This is simple, powerful thing. Just do an order by manufacturer, or you can just put order by one. My select list has one column, so if I put order by one, I'm ordering by this. We've talked about that. Or I can just make it explicit and just say, hey, order by manufacturer ascending. That's the default. And if I run this, so if you order something, this is exactly what I was talking about. You see? So it is telling you 186. It doesn't mean that there are 186 manufacturers. You see, some manufacturers have been listed more than one. So when you tell you the list of manufacturers, your manager does not want to see this. This is crazy. Right? This is not what you're supposed to do. Right? So who can tell us the appropriate way? So you see, it's an easy way I investigated. In this table, does every manufacturer occur just once? That's not a question you're going to ask your manager. You can investigate it. Just throw in an order by and run this. See that? And you see right here, add view, it's a manufacturer, and you can see the number of times they occur in that table, 18 times. So if I just tell my manager here, we have 186 manufacturers, that's a false information. I've done what we call duplicate count. I've counted a certain manufacturer multiple times. That's multiple counts. See? And see, an order
We have,
by will help
we
you to
have to use
decipher.
the we have to use the mistake operator.
Excellent. You have to use the distinct. Right. Please remember that. Right. So I'm just going to step in right here and throw in the distinct right here. So distinct. And this will give you the distinct list. Even if it's not introduced in the requirement, you have to understand that, right? You cannot go into a restaurant and they give you the menu and you see the same food is listed on the menu 10 times. That's crazy. See? So how do you solve that concept of, duplicate data on the list? You just put a distinct in front of the column. If there are 10 columns, it's just one distinct. Any number of columns is just one distinct. And this is it. See? So there are 12 manufacturers, and this is the list. You see, a list, that's it. You have to see the names of the manufacturers listed out. And you see, it kind of ties with what you see right here. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right there. Right. And then you see, so we've already achieved this part. And now we're just going to add another column for total sales, add another column for total profit. But then this exploration is very important. See, always remember EDA, exploratory data analysis. Every analyst does that. They don't just give you a business requirement. You get excited and you just jump into it and start, throwing stuff left and right. No, take a moment and analyze, do some exploratory analysis, explore the table, get to know the first understanding. Hey, this is a CVS, it's a pharmacy. They buy their products from different companies. These are the manufacturer. As we go ahead, I will bring what we call a data dictionary, which is simply a document that explains each column you see in the table. I will bring that for Adventure Works. I'm going to bring that thing on the 4th week. I have plans for that. So that's a data dictionary, right? So the tables you see, the columns you see in the table, they have explanation. Not every company has a document. It's called a data dictionary. See, I will send a copy of that next week so we can discuss, right? So that is very important. It gives you the domain knowledge, right? A data analyst can work across any field, any domain where, as far as data is being collected, they need somebody to analyze that data, right? So the first thing you do is understand the domain. What type of data do you have in front of you, right? So these are little explorations we are doing, and we are gaining some basic insights into the data, right? So that's the first insight we've got. There are 12 manufacturers who supply drugs to CVS. See, very important information we've got right there. So there are 12 right there. Right, and then the next thing we're going to do is the list of, okay, now this one talked about list. Let's just jump into the numbers, and the number is what the 12 you see, right? So how do you generate a query that will just give you that 12? You don't need to go right here and see 12 rows, or you can check 12 right here, right? This is going to be what a counting process. Number of, it's a counting process, right? So if you're with me on that, I'll just do this first two and then I pause so that you can catch up. I know as I'm talking, you're also typing. All right, so this is now going to be a counting process. And if remember that distinct has to be part of that. So you have to do what we call a count distinct. It's a continuation, you see. Let me show you what we get if we dismiss the distinct. First of all, this is the correct thing. You're going to get at 12. And we all understand how this 12 came about, you see. Right. Now, if you dismiss the distinct, there's a difference between count and count distinct. Now, this is the misinformation you gather. So we are back to that 186. These are the 186 rows that are available in this pharmacy sales table. Right. The very first base query we ran right here. These are the rows or the records. This table has 186 records or 186 rows. This number is not a reflection of the number of manufacturers, neither is it a reflection of the number of drugs. This is very important, right? Right. So the understanding that one manufacturer can show up multiple times on that table, it's a very important realization. That's why we have a distinct right here to take care of that, right? And also in the counting process, and take note, this is some little confusion that students do, but of course it's a little thing, but when you run it, you discover it, you fix it. The distinct is not placed outside. It goes into the parentheses. Right? It is, yeah, when you practice, you see these things, of course, you fix it and you learn, and that's the key, right? So when you make errors, it's not something you should, stress yourself over. Those errors are meant to build you. You learn from those errors, you see. So you have to understand now why we put a distinct right here. This is a difference between count and count distinct. Right. So without this distinct, we are doing the regular count, and we will be counting. We'll be doing basically duplicate count, counting a certain value multiple times. But then the distinct helps to eradicate that duplicate count scenario. And this is the number of manufacturers. That's going to be a long column name, but let's just put it right there. Right. So this right here is a number of manufacturers. See that? I think, let me just pause right here. Please, if anything is not understood, make sure you draw my attention. I can come to your screen. It makes life easy. We take a look at it together. Right. If you have a syntax issue and you don't struggle with it, please just let me share your screen and we take a look at it. Right. Normally, I don't like when things are going too smooth. The learning process is much more better when you have those errors and you see me struggle to fix the errors, and I throw more explanation so that you get to learn more when things are going on smooth like this. Right. Now you understand, if I kick this out and I also kick this out, certain things I just assume, you get an error. Right. You should be able to understand why this error is because of the space. So names of columns, no space. If you must put a space, then you have to make sure you force these three words together. And how do we force that in SQL? Is the square bracket, this and this, right? So I can change the naming convention right here to the snake approach, where I just use an underscore to connect the words. So I'm getting rid of the spaces. In that case, this becomes now a nuisance. This is an error source. I have to delete that. See, all right, now I'm good. See, so it depends on the naming convention you want to use. All right. Okay. I think you all are familiar with that. See, keep practicing, keep working on this, and that's how you build your expertise, and you build your experience on that. All right. Please make sure as you type, you save the document. Right. So this is just for the manufacturers. We've seen the list of the manufacturers, that's seen the names listed out. Right. That was just what I wanted to highlight. Listing things out and then counting them. This number of manufacturers. I just want to see a count of those. And those two information types, you see. We're going to do the same for drugs. Right. Let me get the base query. This is the base query right here. Right. So once you see the focus of this is on drugs, just isolate that column. This is it right here. Isolate the column. It's the drug column. Just go there and isolate it. Right. Kick out the asterisk and just target the, see, we're getting rid of any distraction. Just focus on that column. Execute. That's how you work gradually, but you know exactly where you're heading to. You see. All right. So list of drugs. Again, this is a list, right? And now we have this. All right. What is an easy way to test if one drug has been listed multiple times? It's just sort on the column you want to test. Sorting is very powerful. I'm just going to do an order by. I can just put one right here, and that's drug. Remember, I cannot put order by two because on my select list, there's just one drug. There's just one column. Sorry. So there's no second column. So one means the column on position one. So you can order by the numerical position of columns on your select list. All right. So this is a quick check. Do you see any? Oh, let me show you one very powerful way to also check this. Yes, this truck is repeating. Let me show you one very powerful way. If you have millions of records, that would be crazy way to do. All right, let me show you a very powerful way to check for duplicates. If every drug occurs once, then what happens? If I put every drug in its own group and I count, then the outcome should be 1. That's an important way to test for duplicates in the data. Put every drug in its own group, right? And then proceed to count the number of drugs. So we're basically counting the number of drugs. So if each drug occupies a group of its own, then that's a count of 1. And then we're going to do what? Group by drug. Please take note, this is a very powerful way to test for duplicate data on a given column. All right, now I'm going to do group because, of course, if I run this query, it's going to fail. Why? Because I have aggregated and non-aggregated mixed together. So I want to put each drug in its own group, and then I visit the group and count. If every drug occurs once, then you have counts of 1, 1, 1, 1 throughout. So first of all, let me fix that error by putting a group by right here. Group by 1, group by drug. In the grouping, let me see, 1, is it allowed? Yeah, if we can do it in the order by, can we do it in the group by? It's not allowed in the group by. You have to put the name of the column. All right, so run this. See, so this particular drug occurs just one time in that table. This particular drug occurs just one time in that table. And if you see this drug right here, it occurs twice in that table. This drug occurs twice, you see. I want to make sure we all understand this little test right here. If you want to test if a column has duplicate values, put each value in its own group. That's the meaning of drug, and then group by drug. So each drug should be in its own group, and then count the number of drugs. If there are no duplicates, then every drug should occupy a group of its own, only one. This is a good examples right here. But as you go below, and now you can bring your order by. See, learning SQL is one thing. Applying it in business problem, that's another thing. See, now I can order by drug. I can just put 1 right there. The order by takes that numerical position. And let me go, since I'm interested in the opposite direction, let me do descending. The ones with higher counts to the ones with lower counts. Execute this, you see. What did I do? Order by 1 descending. I thought I saw higher counts. No, I made a mistake. I did order by 1. This is not correct. This is 1 that's struck. That's in alphabetical order. I need to order by 2, which is a counting process. You see that? So 2, execute, and this is it. So yeah, this struck occurs 3 times in the table. See that? This struck occurs 2 times. So this tells you if you want to do a count of the drugs or list of the drugs, you must do this thing. Please, I want to stay right here and make sure you understand this. So we're going to transform this name to what? Testing for duplicates on the drug list. Right. Just permit me to change this title. Right. This will be testing for duplicates. So duplicates are drugs that occurs multiple times. Testing for duplicate So testing for duplicate drugs. So first, very important, show each drug in its own group. That's why we do the drug and we put the group. And then visit each group and count the number of drugs. So we're doing count on drug. If each drug occurs only 1 time on the list, the count will be 1. If the drug occurs 2 times, the count will be 2. See, we're taking each drug, put it in a group of its own. So ciprofloxacin, there are 2 instances of that drug. See that? All right, and you can actually show proof of these things. All right, let me dismiss this list of drugs. Let me just dismiss the counting process, show only the drugs. In this case, I'm going to order by 1, and then the group by order by drug or 1 ascending. Let's put ascending right here. I just spotted this drug, so we can test this one. This drug right here, I'm not going to attempt to pronounce this name. It occurs 3 times. This is D. So I've sorted this in alphabetical order. I'm going out to the full list of drugs, and I want to show you the 3 instances of that drug. So go to the D section. D section. Let's keep going down to D, B, C, D. Let me just go to that drug. This is the drug right here. Actually do a combination of upper and lower cases. This is the drug right here. These are the 3 instances. Remember we talked about the SQL not being case sensitive, so upper or lower case, so you make sure it's the same. This is the same drug. 1, 2, 3 instances. See, same drug. This drug is different because of the names. This name is different from this, right? And each value you see in the summary, this is summary. Meanwhile, this is detailed, right? So let's go to the next one. We check this counting process. This drug ciprofloxacin occurs 2 times. Let's go to the detail side. The detail side is this. No counting or aggregation is done. We're showing each drug as the way they occur in the table. That drug is on the C side. This is it. 1, 2. 1 instance is not showing up. Oh, not 2. Sorry, it was 2 instances of that drug. So let's go back to the table. This one, execute. This right here is 2 instances of this drug. See them? 2 instances of ciprofloxacin. Let's go back to this and verify that information. And this is it right here. So basically this drug, when you say group by, since it's the same drug, it is placed in a group. So that group will have 2 of it. And when you use now the count on the group, so you show a group and then you visit each group and count. This is a group because it's the same drug. So that's when the count now returns 2 because this is 1, this is 2. This is very, very important. So first, the grouping is very necessary. When you say group by drug, all drugs with the same name should be placed in one group or one bucket. And then show me the bucket and then count the number of drugs in the bucket. That's why this group by is very powerful. Right? Once you start seeing this mixture, non-aggregated column is drug, and aggregated column count has been added to drug, so it's aggregated. You have to put the group by. Right? So this is an easy way to test for those duplicate. Let me just put testing for duplicate data in a given column. This is more generic, more general. See, testing for duplicate values or data values in a given column. So what is the strategy? List out the column, do a count on the column, and then group by that column. This will help you. And you can go ahead and order by just to see that. And this is it. This is very, very important. Let me show you proof of this concept from a different table. You all have academia. I'm just going to connect to academia. Right, I'll take you to the student table. Every student must have one ID, a single ID, which is not shared by any other student. Right, and I'm going to show you that because in the student table of academia, there is a primary key. And the primary key is simply a column that cannot be, a column whose values can never duplicate. So we have the student table. If I go to the columns, I'm going to show you a key right here, and it's PK. So a primary key is a column whose values are unique. So no 2 students will have the same student ID. So in all columns in all tables where there's a primary key, you can go and test that concept, testing for duplicates. Let's test duplicates on student ID. So show me student ID. Oh, sorry. Let me first of all put the name of the table. Right. Usually, if you don't put the name of the table, the system will not be able to help you in the typing of the columns. Right. So always declare the table you are working on. I want to use the student table. That's a good, right? And now if I start typing, the system knows the table I'm looking into and it can help me with the column names. Right. So this is it. Let me just make sure I run this too. Right. So how do you test for duplicate data on student ID? Show student ID and then bring a count on the column you're testing. Count on the column you're testing. And then make sure now we are dealing with a mixture. Aggregated true count, non-aggregated. What does the logic says or the rule says? Copy the non-aggregated and place it in the group by. If there are 50 of them, you have to copy all 50. So all non-aggregated columns must be placed in the group by. This is a test. We want to see if two students have the same student ID. So each of these values, we are putting them in a group and then we are visiting the group and we're counting. Execute. You see all of them is one throughout. See? So there are no duplicate data on the student ID. What does that mean? No two students have the same student ID. And usually in a test scenario, you're just going to ask this question. You add a haven't clause. If there are duplicates, then the count should be greater than 1. Can somebody explain why I put that condition on having? Why did this condition go into having? Why can't I not put that condition on the where clause? These are these two things that you will see a lot in interviews. This is second version. It's when you put this in the where clause. That's where the where clause fit. Sweaty feet will give horrible orders. These are two nice looking queries. In fact, when I go ahead and test for the syntax wise, see this one executes to correct. I go to this one and test syntax wise by just clicking on this check mark right here. You see, they both evaluate correct syntax wise, but there's a serious logical violation on this one. See that? The reason is because we are putting an aggregate function directly on a where clause. And we said from last class that an aggregate, anytime a condition involves an aggregate function, it should be placed on the haven't clause, not on the where clause. This checks syntactically is correct, syntax wise is valid, but then upon execution, right here, execute, that's when you realize that hey, there's a serious error in that code. And that's, you see, interviewers like this. They're just going to project this on a PDF document and show you, read through this code and tell me if it's valid. Right? And that's the same question we had from the last class. If you go to, I think that's day 2, concept check MCQs. I think the very first question, this question I got from LinkedIn. LinkedIn has a test on your SQL knowledge, SQL to prove your skill set on SQL. All of these questions are coming from LinkedIn. And you see, it's a vital test on that. The idea of placing an aggregate function, a condition with an aggregate function on the where clause, it doesn't work. And see the technique right here. Is there an error with this query? The answer is yes. If so, which statement best describes the error? And of course, we conclude that it's going to be the first one. Yes, a where clause cannot be placed in and with an aggregate function. So the first part, is an error in this code? The answer is yes, there's an error. And what explains the error? A where clause, an aggregate function has been placed on the where clause. See, there's the same mistake right here. This is a where clause. We've placed an aggregate function on the where clause. Execute, you get an error. You see? So you should never do that. When you write down a condition, if the condition involves any of these aggregate functions, there are just 5 of them. Right, the 5 of them we've seen, you should know this even if you wake you up from sleep. These are them right here. There are so many other aggregate functions, but these 5 ones have serious business implication. Right, that every data analyst must know them. Right. So this is very important. This query fails. You should be able to explain why that query fails. And this is the valid way to go around that. So each time you write down a condition and the condition involves any aggregate function, please take that to the having clause, not the where clause. So if you're testing for duplicate values in a given column, this is the condition to put in. If the count on that column you're testing is more than 1, then there's a duplicate. If not, you have an empty set. Empty set shows that that column is clean, there are no duplicates. Right. I will come back to the same concept. It's just to push it out there so that you're familiar with this. Right. So it is in line with the primary key concept. Right. So let me go back to that test. I want everyone to work on that test, execute it so that you see something that just came up and you see that. So we're right here testing for duplicate values in a given column. And this is it right here. So you now see that if you bring that in that test, which is the condition is having goes into the group by. Sorry, having goes below the group by. So the having is going to go right here. All right. Having, we're not testing what count greater than 1. So those drugs that have duplicate counts, they're going to show up. We are just focusing on those that have counts of more than 1. And these are the 6 drugs that occurred multiple times. This one occurred 3 times, 2, 2, 2, to see. So this is very important information. And now on the listing of the drugs, you must put a distinct right here. See that? This is very important because this discovery right here directs you to put a distinct right here on the listing of the drugs as well as on the counting of the drugs. Right. So if I run this, this is it. Remember, we used to have 186, but then we've shown the distinct drugs. Without that distinct, you will get the duplicates also being listed. You see, we talked about ciprofloxacin, 2 instances. And there are several other drugs that this one also 2 instances, you see. So with the distinct, you get rid of that duplicate listing or multiple listing of the same drug. Excellent. Also, implication on the counting process. Right, on the counting process, you have to do a count distinct on the drug. So you're just gonna introduce count right here. Distinct goes inside the parentheses next to the column name, not outside. And this is how you end up having, there are 197, 179 distinct drugs. And that's the same thing we saw on the listing of the distinct drugs, 179. Right. I think we've covered something very crucial. Let me stop right here. Please, can you go ahead and achieve this? So first, the testing of the duplicates for that column, and then the listing of the drugs. Distinct features right there. We know why. Right? Number of drugs, count distinct on drug. Right. And anybody asking you why did you put this thing? Why did you go for count distinct and not count? You can explain that. This is from this finding right here. These are the list of drugs with multiple occurrences on that table. See? And so having realized that, now to show the list of drugs, we have to put it distinct. We don't want any drug to be listed more than once. See? And that's how we arrive at this. Also in the counting process, we want to do a count distinct. No, the same drug should not be counted more than once. That it's going to mislead the business. So that you're confident that there are 179 distinct drugs on that table. Right? No drug has been counted more than once because of the presence of the keyword distinct. Right? So that's a nice build up before we get to solving this question. Let me just take a let me pause right here. Please, if I'm too fast, slow me down. Let me see. So these are the 3 things we've talked about on that. I want to see if they can fit in a single window. Make sure you save, right? As you type, save the script. Okay. So now at least we are prepared for this. So first of all, we know that there are, from our exploration above, there are, I think, 12 manufacturers. So we want to show each of these 12 manufacturers. We want to show the list. These are the 12 manufacturers. We're going to show each of the 12 manufacturers, and we're going to show next to them their total sales generated and the total profit. And that's the three key columns that are visualized right here. Remember, we cannot build visuals in Management Studio, but we can evaluate the key columns that were tested in this visual: the manufacturer name, total sales, and total profit. Right. Now, if we put those three together, we should be able to solve that question. Right. So if you go to this one, total sales and total profit by manufacturer. Right. So first, we're gonna begin with the manufacturer. Right. I always like to begin with the something they call the categorical data, something that is descriptive. Manufacturer is descriptive before you go to the quantitative things that can be measured. Right. Okay. So this, of course, for the total sales, I think we've done this somewhere above. And this will be the total sales. This is the expression we use for the total sales. Same thing I'm just going to put right here. Right. For profit, we did talk about profit. You can use one of these calculations. You can go with this, or you can go with this. That will give you the total profit, something we built above already. So those are the three. And then if you execute this, of course, you're going to get an error. Right. Out of three columns in the select list, the select list again is a list of columns you have on this portion. We have manufacturer, total sales, and then this logic right here, which generates one column. and these are aggregated. So we have two of these columns have aggregations, while one is non-aggregated. So always remember the non-aggregated one goes to the group by. This is something that you should always remember. It is very, very important. It's a source of a lot of errors on execution, right? Especially on the analytics side. And this is it. See that? And if you go back to this visual, you see, let's see, let me show you the visual and let's talk about this. Let me go to this interactive part. On this visual, let me just go to the visual itself. If you notice, a sorting was done. Okay, let me just go ahead and sort. All right. So I'm clicking on this button. This is sorting. These are the two buttons for sorting. This is ascending. You see, small goes all the way to the bigger side, and this is descending from the bigger side all the way to the smallest. All right. And now you can look at this. This is what this is the total sales. So let's sort by total sales. Right. If we go now to our query, sorting is done through what the order by. This is very important. So sorting is done through the order by clause, and we are sorting by what? In the order by, feel free to use aliases. So if you want to sort by total sales, you can copy this and put in the order by that, or you can use the alias. That's the only spot where an alias can be applied in the order by. So now we can order by total sales descending. You see that? Descending. And when we run this, the manufacturer with the highest total sales will be displayed first, followed by, you see, and that's the same arrangement we are having in this visual. Let me go to this visual. I've sorted. Let me go back to the dashboard and you can see app view followed by Eli Lilly. These are, and then Biogen, Johnson and Johnson. See, that's the same thing we are getting right here. I GSK is generating the lowest total sales, right? And you see right here at the bottom, right? So the goal of this is just to look at the visual and start challenging yourself on the query that runs behind the visual. This is preparing you towards the dashboard design and build process, which is going to be the second model, right? And on this pie chart, what are we just doing? We are tracking the total units sold by manufacturer, and then you can now project that information as a chart, as a pie chart. SQL will just by default gives you the tabular outcome, the table outcome. You see, all of these are tabular stuff. You run this, you get the outcome as a table, the columns, see, right? So you read the visual, you interpret it, see the key columns that was used in that visual, and you can now translate it into a business requirement. This is the total units sold by manufacturer. You see, I've now translated this image into a business requirement. And then from there, you can go ahead and build the SQL query behind that process. So total units sold by manufacturer, total units sold per manufacturer or by manufacturer, same thing, right? And now you can transform this business requirement and you can write the query behind that process. Always start with the base query, right? You want to see, we've discovered the manufacturer column is available in that table. Now, what are we going to use for the unit sold? Is there a column for that? This is very important. There's a unit sold column. So every requirement is available for this project. It is very, very important that before you start analyzing any project in a company, make sure you have all the requirements. Right. So you read the question, go to the table and see what's available. Total units sold by manufacturer. We have a manufacturer column. We saw that earlier. It's available right here. We also have the unit sold column. That's it. So to get a total unit sold, we just do summation on this column and we project that for each manufacturer. You see that? And that's it. Right. It's really that straightforward, easy. Right. So show me each manufacturer. Again, I always begin by showing the categorical side, and then we now track the measure, the quantitative side. Right. On the quantitative side, what are we doing? We are targeting the unit sold column and we are summing it up. So summation on the unit sold, we have a column called unit sold. This is it right here. And this will be the total units sold right here. And we're going to project this per manufacturer or for each manufacturer, right? So total units sold. And of course, now you understand that we have an issue right here. Execute this, we get an error. We are dealing with a mixture of a column that has been aggregated and a column that has not been aggregated. Take the non-aggregated one and put it in the group by. This is very, very important. So we're going to group by that. And now if we execute this, execute, we see this, right? And you can proceed to sort. Managers always like when you sort things out so that they don't go looking at what company had the highest unit sold. Just always present data in its desired format. Let's get the total units sold. So we're going to be sorting or we're ordering by the total units sold. Let's do descending so that the manufacturers with the highest total units sold, right, gain this right there, you see. And if you go to that pie chart, it shows each pie corresponds to right here. And I did add the percentages, the proportion, right? I'm going to show you how to calculate that one next time, right? So we are not only showing the total units sold, but we're also showing the percentage. So the whole of this is 100%. So this part right here is accounting for what 18% of that total units sold. Right. So if you sum up all of these percentages, they hit 100. So uh, you can see from a visual perspective which manufacturer had the highest unit sold. Right. That's the visualization process right there. Right. From a SQL side, this is just going to be in a tabular format. Track down the key quantities in the chart, which show the manufacturer and tell us the total units sold. And make sure you sort it out. And this is it. Now, on the side of calculating the proportions, I will show you how to do that part. That part is actually easy. What's the proportion? It is just the sum of this divided by the overall. Sum of each of the individual one divided by the overall. But if you try to apply that, I'm going to push that to the next time. Right? There's something we have to do that we have to use a subquery to achieve that. Okay, so let's work on this tool. Let me know if you have any issue on this. Right. And make sure you save as we proceed. Okay, are we making progress? Okay, I want us to talk about this one right here. So this one is the drug insights, and I want to actually show you how this works on the dashboard. It's interactive. So there's a number, right? There's a parameter right here. You can just enter. For example, I want to show the top. So N, you can control what N is on this. This is a parameter. You're going to see that when you're building dashboards. So the user can specify what number of drugs they want to see right here. This is just tracking down the profit of each drug, right? So if I request for the top 5 drugs with the highest profit, that's my N, and I click on enter, it's going to filter the dashboard, and you see I've also made sure this is communicating with whatever number you put right here, right? If I change this to 10, click enter, it now projects the top 10 profitable drugs. So we are tracking profit on this. So you're just doing profit by drug. See that? So you're showing the top, in this case, 10 most profitable drugs in the company. If I do 30 on this, enter, and you see it right there. I remember we did this analysis on drugs. How many drugs did we? So how many distinct drugs did we come up with? If you do a count distinct on drugs, execute, there are 179 drugs, right? So you can always do this interaction. Show me the top 50 most profitable drugs. That's drugs with the highest profit, the first 50 of them. And these are them listed right here. See that? All right, so I want us to do this, and we're going to talk about the top clause. I think we talked about that last time, but I want us to talk about it. All right, so the requirement here is top. Let's get that requirement top. N. N can be anything. You can control that. Profitable drugs. Top N. Right. So again, let me just get the base query, and then we can put that together. Base query is going to be this. So what are we tracking? We've seen the columns. It's a drug column. We know that. So we're going to be showing each drug. And what are we going to be tracking? We're going to be tracking the profit. We did a calculation on profit. This is unit sold. What's that profit calculation? This is it right here. Yes, we can just copy that. So we are showing each drug, and we are tracking this profit stuff. Again, execution of this will fail. You need to put the non-aggregated column on the group by. So I'm going to put this on group by. Right. And now if I execute this, so it will show you all those 179 drugs. Please remember that's the number we got from this exploration. Number of drugs, count distinct, 179. So in this analysis, we are showing you all the 179 drugs and their profits, total profit, all 179, right? Now, the next thing you can do is a sorting, right? Now, let's sort this. Remember, sorting is done through the order by clause. Let's sort by what? Total profit. And let's do descending so that the drugs with the highest total profit will be on the top of the list. Now, if I execute this, the sorting is going to take place. So you mirror, that's a drug, and it has this as total profit. If I go back to that chart, you see it's the first right there. It's 2 million something. Right? That's the formatted, right? It's right there. See? And all the way at the bottom of the list, we have that, right? The negative ones, negative profit. That's a loss, right? Now, the aspect of getting the top N, where N could be any number, it always works with the order by, and you just simply put it right here, top. top and you specify any number. So if I do top 5, right, I want to get the top 5 drugs with the highest profit. So when you're using top clause, always remember it goes with the order by. I should take you to the notes and show you where this particular segment is coming from. It's towards so this is week 3, day 2, this lecture material right here. You see the concept of the top clause all the way towards the bottom. I remember this is the end of this document. This is what I'm addressing. Right. The top clause allows you to limit the number. You can do number or percentage of rows that your query will return. And the secret is just right here. Put top and you put a number. For example, give me the top 3 first name, last name, and stuff like that. See, if it is a percentage, you just put top 50 and then you put the keyword percent. But usually we work with numbers. So the sorting must be done. Top 5 based on what? So the order by answers that question. Right. Give me what is the best country in Africa? What would be the next question based on what criteria? So it is very important to remember that when you're doing the top clause, the order by is very, very important. Right. The order by must be there to, dictate the criteria on which top is measured. See, and that's why we first of all sort. So this has to do the job. This one has to sort, and then based on that sort, it now extracts this. If I say top 5, this is what's going to pick up because the arrangement has already been built. All right. If I go this way, top 10, this is what I get. See, right. And talking about top, there is no bottom. Right, there's no bottom clause. Let me just bring the top. Right, you cannot switch this to bottom. It doesn't exist because if I now ask what is the 5 worst drugs with the 5 drugs with the worst profit performance, you're not going to replace bottom. See, there's a top clause, but there's no bottom. Right, for the bottom part, you have to switch from descending to ascending. So let's first of all address the top. So top N, most profitable drugs. If N becomes 5, now we're looking at the top 5 drugs with the highest profit. And these are the top 5 drugs with the highest profit. That's the same thing you get in this visual. If you go right here and put 5, click enter. These are the 5 right here. See? So in SQL, this is what you do. You use the top clause. If I switch this to top 10, see, I will get the top 10 drugs with the highest profit. See, then that's increased to 10. See? If I switch this to 20, I will get the top 20 drugs with the highest profit. Right. Now, if I want to look at the worst performing drugs, that will be the concept of you have to flip the table. So bottom, so for the bottom, you have to switch this to, let me show you how this is going to look like. So if I remove this and I put ascending, so what does this mean? Drugs with the lowest profit should be at the top of the list. That is the worst performing drugs. See, I've switched it. Before we had Humira with the highest profit, 82 million. Right, we have now switched the order of the table. We're switching to ascending. So this is where the real Z takes place. So if you're putting descending, you're looking at the top performing drugs in terms of profit. See, from the highest all the way to the lowest. If you switch it to descending to ascending, sorry, you're reversing the order in the table. Now the drugs that were in the bottom, that's when they come now to the top. So you can still stay now with the top clause. If I put top right here, this top is now selecting from the bottom. So top 100 drugs with the worst profit. These are them right here, you see. And see they're all negative. So please take note, there's nothing like bottom. You stay on the top, but you reverse the order of the table. Ascending, you see. This right here is descending. So this is best performing drugs in terms of profit, top 20. See, highest to the smallest. You see, this is very, very important, and you can read more on this in this concept. Right? Are we okay? Everyone is quiet. Are we good?
We're good,
Anita?
sir.
Okay.
Yeah, so I noticed that there are some words that you must write them in, you must capitalize them. Oh, I don't know.
Oh, that's a good point. So yeah, all of these words you can write all of them in small letters. Right?
Okay,
Remember, we in the beginning we said that SQL is not case sensitive. So if you look, I'm just writing them uppercase so that they look bold and then you can learn them easily. You see that, so when
okay,
you look at a code like this, all these bold words, you kind of attract your attention. But you can transform all of these into small letters. See, it's not going to be an error. So I can transform all of these into smaller letters, small cases, small lower cases, sorry. And the syntax is still valid. That's a very important question. Right. So when you're practicing, you can choose to say, hey, you know what, I'm not going to use upper cases. Right. Right. So you can still do this. Right. And see on this side ascending, even on at the level of the names, you see, I can decide total profit. I can change it to all lowercase. It's still gonna be valid. See, and if I change it right here, I need to also make sure change is implemented on this. See, so even on the level of the functions, right, instead of uppercase, you can do lowercase. All right, this is a very important question. You see, so this the case uppercase or lowercase does not matter. It's the same thing right here. Right, and I've done the transformation all lowercase and I execute it. It's the same. See that? That's a very
mm,
important question. Right? Are we okay?
very good.
Okay, that's a very important question. Right? So please practice this. I've also sent a screenshot of this on the WhatsApp group. Hopefully this lecture today helped. And for the lab, I didn't focus on that a lot because I know that the solutions are right there next to the equations. So if I go to, let me just target one of those questions. This is this one right here. We are using the inventory. So if you click on this link, and if you read through the questions, you see, you can always check out the solution. So it's a lot of it's going on right here. So you can always check out the solution. So this one says calculate the total purchase of all orders. You're just targeting this is the purchase amount column and you sum it up. Right. And what you do if you want to check out if you did it right, this is just click on this, click me to see the solution with visual presentation. Right. So all those 25 questions you can always check, and this is it. So since we asked to calculate the sum of the purchase amount, you just summing up that column. And then from the other table, that's it. Right. And this is very important. And if you want to see the visual process behind that, this is the query you wrote sum on the purchase amount. So it targets the purchase amount column and it does what the sums of all the values top to bottom. And this is what you see, it extracts the column first, the sum function, sums of everything. This visualization helps you. So if you did not see that, please remember all of these questions in this. When you click on that link, the solutions are just directly below. You can click check. Right. So that's why I don't really invest a lot. But if there are any difficult questions on this 25, you can draw my attention to that. So I will encourage you all to create time and go over all these 25 questions. We are using the inventory database. Right. These are simple, straightforward questions. Please practice them. Right. Same thing on this one. Calculate the average. It's the same on purchase amount. The first question we're looking at the summation on the purchase amount. This one is looking at the average. So we're going to use the AVG function. If you look at the solution, we'll switch now from toward average. It's just right. Very important. Read that and then go to the bottom, see how the visualization is, the demonstration of the process. This is the average. We are averaging all the values on the purchase amount column. Right. These are things I want you to see, practice these things and understand them. You see, question 3, count the number of unique. So this is a count distinct. Very important. You must do a count distinct on this kind of stuff. Right. On the salesman ID, count distinct salesman ID. You see 5002 is repeating 5002. If you just do a regular count, this will be counted 2 times. And you see this serious list others see. And when you talk about the unique salesman, right, there must be a distinct count. If you check out the solution, right, you're gonna see there's a count distinct on salesman ID. So please create time and go over all those 25 questions. If there are any challenging ones, draw my attention to that. Very, very important. Right. Are we okay? Tunde, are we good? I haven't heard your voice. Are we okay, Tunde? Okay, yeah. So please take note. This is very, very important. Right. All those 25 questions, you can consult the solutions. First of all, solve them and then you compare your outcome or your code with what is presented on that. Right. And if there are any aspects you don't understand, just let me know. We're going to solve that together. Week 4, we're going to be doing joins. So this weekend is going to be a very, very important session. If you just look at the from clause in all the questions we've solved today, the from clause carries 1 table. You could ask me, is it possible to query multiple tables? Right. I want you to give me student information and also questions on the courses they are taking. So show me a student and tell me all the courses they are taking. Right. So I'm pulling information from the student table. I'm going to the courses table and pulling information. So those are multiple table queries. So this is the 3rd week of the training, and every single query we've written is called a single table query because the from clause carries only 1 table, single table queries. Right. But this is not always going to be the case in a business scenario, in a real life work environment. You will be challenged to pull data across multiple tables. Right. Show me each employee first and last name and tell me the department they work. You see, the employee's first and last name will be getting from this, the department name from this, you see, and the salary information, you see, they are spread across different tables. Can you pull all these 3 tables together and extract different columns across them? The answer is yes. And you do that through what we call joins in SQL. So joins is how you combine 2 or more tables and you project the information across those tables, right? So everything we've done for the first 3 weeks, single table queries, you can confirm that for yourself. Go to every single query we've written. Notice that the from clause carries a single table queries, single table query, single table query. You see, all of this. All right, so week 4 is going to be an interesting week. We're going to see how to do a multiple query, multiple table query. We're going to be returning data across multiple tables. Right. Are we okay? Okay, I want us to stop right here. Please, if you need this document, anyway, I'm just going to go ahead and send this document to everyone. You can compare with what you've built. Right, I think I'll save this document and send it to everyone. Okay, we're going to end here today. I'll see you on Saturday. Okay, good night, everyone.
Good night.
Okay, see you on Saturday. Yeah.